Hello, my name is Sunil. So, I have made a project based on approval, based on real data set and also the emergency they come through. So, my project name is Real-Time Posture and Movement Analytics for COMA Patient Risk Detection. Now, I will explain the workflow of our machine learning model for real-time posture and movement analytics for COMA patient risk detection. So slides goes through by problem statement, workflow design, and clear explanation for presentation. So here is the workflow of my project. So we start with the data retrieval step where we collect coma patient data from our dataset. These datasets include posture and movement related features which are important for risk detection. So here is the dataset we have, which I have added for my project. So next we move to setting roles where we define which attributes is the label and which are input feature. This helps the model understand what it needs to predict. After that we split the data into training and testing sets. The training set is used to build the model and the testing set is to evaluate the performance. Then we apply outlier detection using the LOF local outlier factor method. This steps helps in identifying and removing abnormal or noisy data points, improving model accuracy. Once the data is clean, we use a random forest algorithm to train our model. Random forest is chosen because it provides high accuracy and handles complex data efficiency. After training, we use the apply model steps to test the model on unseen data. This gives us prediction based on the trained model. Next, we evaluate the result using the performance model, which we measure metrics like accuracy and predictions quality. We also perform a joint operation to combine different dataset or result for better analysis. Then, in the general attribute step, we create new features or modify existing ones to improve insight. Finally, the results. So here you are watching through is the graph for apply model visualization. This graph represents the sensor data collected from patient from MPU 6050. So this is a hardware part of a project where I have collected the all the measurements of the coma patients. So then I have added the datasets of Excel sheet to Rapid AI Studio. Here we can see different parameters like accelerometer values and gyroscope values plotted over time. So next come the yellow region represents the overall movement of train, while the other lines show variation in different axes. For example, here we can see a value around 10 for accuracy. Yeah, 10 for accuracy Z. Z is the axis which indicates stable vertical acceleration due to gravity. Any sudden deviation or fluctuation in these values can indicate abnormal movements which may correspond to a critical condition like this. So next comes the dataset values. Yeah. This table shows the process data used for prediction. Each row represents a patient instance identified by patient ID. We have features like accelerometer, gyroscope, and total movements. The condition column represents the predicted state of the patient, such as stable, improving, or critical. We also included an outlier score, which helps identify abnormal data points. So here is the condition of like stable, improving, critical, improving. The patient numbers, totally we have 100 patients, all monitoring in one. Next comes the performance, performance vector performance. Yeah. Now coming to the model performance, our model achieved an accuracy of 83.33%. That is true improving, which indicates a very good prediction performance above the accuracy point of 90.95.24%. Out of all stable states, 7 were correctly predicted for improving, 5 were correctly predicted for critical, all 8 cases were correctly classified. The precision for improving and critical classes is 100%, meaning the predictions are highly reliable. The recall is also very high, showing the model successfully identified most of the actual cases. So this shows that our model is highly accurate and reliable for detecting patient condition, making it suitable for real-time healthcare monitoring applications. Thank you.